Right, so we're going to be looking at question number 13 from the revised higher 2013 physics paper. And it says ultraviolet radiation causes the emission of photoelectrons from the zinc plate. So we've got photoelectric emission. This is the photoelectric effect. The irradiance of the ultraviolet radiation on the zinc plate is increased, which row shows the effect that this has. So there's two possible options. One is related to the maximum kinetic energy of each photoelectron, and one is related to the number of photoelectrons emitted per second. So what we're told is that, and I'll draw this, just a simple picture of this over here. We have a piece of zinc. So this is the zinc here. Typically what you might have if you've got an electroscope is you've got a stem and a leaf. That would be the leaf, and there'd be these negative charges if it was charged negatively. And I'll just change the color of my pen. So little photons would travel in, and these photons are ultraviolet. Maybe I should have done them in purple. Never mind. Well, they'd be invisible anyway, wouldn't they? Of course. So they shine on, and that gives the electrons enough energy to fly off with a certain amount of kinetic energy, assuming the ultraviolet radiation has a greater kinetic energy than the work function. And so the equation for the kinetic energy is that the kinetic energy of the electron emitted is equal to the energy of the photon, which I'll say is E, minus the work function, which I'm just going to call E naught in this case. Sometimes it's called W. So let's address each of these points in turn then. The maximum kinetic energy of the photoelectron. So the kinetic energy of the electron, called a photoelectron, that's emitted is dependent upon the energy of the photons and the work function of the zinc plate. So does the energy of the photons change when the irradiance is increased? No, it does not. It doesn't change the energy of the photons because the energy of the photons is dependent on the frequency of the photons, not the irradiance. And the work function also has not changed either of the zinc plate. It's still zinc. So in that case, there would be no change. So our options are B or C because we've got no change there and no change there. So then if we look at the number of photoelectrons emitted per second, it's either going to be increases or no change as well. Now, what irradiance really means is it's a measure of the number of photons that are hitting the zinc plate per second. And so if the irradiance increases, that means there are more photons of a high enough energy to cause photoelectrons to be ejected. And so because there are more photons, more electrons will be emitted or ejected per second. And so the number of photoelectrons emitted per second must increase. And so therefore, our answer has to be B.